A vocoder is a category of voice codec that analyzes and synthesizes the human voice signal for audio data compression, multiplexing, voice encryption, voice transformation, etc. The earliest type of vocoder, channel vocoder, was originally developed as a speech coder for telecommunications applications in the 1930s, the idea being to code a speech for reducing bandwidth for multiplexing transmission. On the channel vocoder algorithm, among the two components of analytic signal, only consider the amplitude component and simply ignore the phase component, and it tend to result in the unclear voice. For the improvement of this issue, see phase vocoder. In the encoder, the inputs is passed through a multi-band filter, each band is passed through an envelope follower, and the control signals from the envelope followers are transmitted to the decoder. The decoder applies these control signals to corresponding filters for re-Eurosynthesis. Since the control signals change only slowly compared to the original speech waveform, the bandwidth required to transmit speech can be reduced. This allows more speech channels to share the single communication channel, such as a radio channel or a submarine cable. By encrypting the control signals, voice transmission can be secured against interception. Its primary use in this fashion is for secure radio communication. The advantage of this method of encryption is that none of the original signal is sent, but rather envelopes of the bandpass filters. The receiving unit needs to be set up in the same filter configuration to re-Eurosynthesize a version of the original signal spectrum. The vocoder has also been used extensively as an electronic musical instrument. The decoder portion of the vocoder, called a voder, can be used independently for speech synthesis. Theory: the human voice consists of sounds generated by the opening and closing of the glottis by the vocal cords, which produces a periodic waveform with many harmonics. This basic sound is then filtered by the nose and throat to produce differences in harmonic content in a controlled way, creating the wide variety of sounds used in speech. There is another set of sounds, known as the unvoiced and plosive sounds, which are created or modified by the mouth in different fashions. The vocoder examines speech by measuring how its spectral characteristics change over time. This results in a series of signals representing these modified frequencies at any particular time as the user speaks. In simple terms, the signal is split into a number of frequency bands, and the level of signal present at each frequency band gives the instantaneous representation of the spectral energy content. Thus, the vocoder dramatically reduces the amount of information needed to store speech, from a complete recording to a series of numbers. To recreate speech, the vocoder simply reverses the process, processing a broadband noise source by passing it through a stage that filters the frequency content based on the originally recorded series of numbers. Information about the instantaneous frequency of the original voice signal is discarded. It wasn't important to preserve this for the purposes of the vocoder's original use as an encryption aid, and it is this dehumanizing quality of the vocoding process that has made it useful in creating special voice effects in popular music and audio entertainment. Since the vocoder process sends only the parameters of the vocal model over the communication link, instead of a point-by-point recreation of the waveform, it allows a significant reduction in the bandwidth required to transmit speech. Analog vocoders typically analyze an incoming signal by splitting the signal into a number of tuned frequency bands or ranges. A modulator and carrier signal are sent through a series of these tuned bandpass filters. In the example of a typical robot voice, the modulator is a microphone and the carrier is noise or a sawtooth waveform. There are usually between 8 and 20 bands. The amplitude of the modulator for each of the individual analysis bands generates a voltage that is used to control amplifiers for each of the corresponding carrier bands. The result is that frequency components of the modulating signal are mapped onto the carrier signal as discrete amplitude changes in each of the frequency bands. Often there is an unvoiced band or sibilance channel. This is for frequencies outside of analysis bands for typical speech but still important in speech. Examples are words that start with the letters S, F, CH or any other sibilant sound. These can be mixed with the carrier output to increase clarity. The result is recognizable speech, although somewhat mechanical sounding. Vocoders also often include a second system for generating unvoiced sounds, using a noise generator instead of the fundamental frequency. History. The development of a vocoder was started in 1928 by Bell Labs engineer Homer Dudley, who was granted patents for it, U.S. application 2,151,091 on March 21, 1939, and U.S. application 2,098,956 on November 16, 1937. Then, to show the speech synthesis ability of its decoder part, the Vocoder was introduced to the public at the AT&T building at the 1939–1940 New York World's Fair. The Vocoder consisted of a switchable pair of electronic oscillator and noise generator as a sound source of pitch, tone and hiss, 10-band resonator filters with variable gain amplifiers as a vocal tract, and the manual controllers including a set of pressure-sensitive keys for filter control, and a foot pedal for pitch control of tone. The filters controlled by keys convert the tone and the hiss into vowels, consonants, and inflections. This was a complex machine to operate, but with a skilled operator could produce recognizable speech. Dudley's vocoder was used in the Sixely system, which was built by Bell Labs engineers in 1943. Sixely was used for encrypted high-level voice communications during World War II. Later work in this field has been conducted by James Flanagan. Applications: terminal equipment for digital mobile radio-based systems. Digital trunking, DMRT-DMA, digital voice scrambling and encryption, digital WLL, voice storage and playback systems, messaging systems, VoIP systems, voice pagers, regenerative digital voice repeaters, cochlear implants, musical and other artistic effects. Modern implementations. Even with a need to record several frequencies, and additional unvoiced sounds, the compression of vocoder systems is impressive. Standard speech recording systems capture frequencies from about 500 Hz to 3400 Hz, where most of the frequencies used in speech lie, typically using a sampling rate of 8 kHz. The sampling resolution is typically at least 12 or more bits per sample resolution, for a final data rate in the range of 96–128 kbits, but a good vocoder can provide a reasonably good simulation of voice with as little as 2.4 kbits of data. Toll-quality voice coders, such as ITU G729, are used in many telephone networks. G729 in particular has a final data rate of 8 kbits with superb voice quality. G723 achieves slightly worse quality at data rates of 5.3 kbits and 6.4 kbits. Many voice vocoder systems use lower data rates, but below 5 kbits voice quality begins to drop rapidly. Several vocoder systems are used in NSA encryption systems, LPC10, FIPS Pub 137, 2400-bit S, which uses linear predictive coding, codec-cited linear prediction, 2400 and 4800-bit S, Federal Standard 1016, used in STUIII, continuously variable slope delta modulation, 16 kbits, used in wideband encryptors such as the KY57. Mixed excitation linear prediction, MIL 3005 Sautom and Principe Dobras, 2400-bit S, used in the future narrowband digital terminal FNBDT, NSA's 21st century secure telephone. Adaptive differential pulse code modulation, former ITU G721, 32 kbits used in STE secure telephone. ADPCM is not a proper vocoder but rather a waveform codec. ITU has gathered G721 along with some other ADPCM codecs into G726. Vocoders are also currently used in developing psychophysics, linguistics, computational neuroscience and cochlear implant research. Modern vocoders that are used in communication equipment and in voice storage devices today are based on the following algorithms: algebraic codec-cited linear prediction, mixed excitation linear prediction, multi-band excitation, sinusoidal pulsed representation, robust advanced low-complexity waveform interpolation, tri-wave excited linear prediction, noise-robust vocoder. equals linear prediction-based equals. Since the late 1970s, most non-musical vocoders have been implemented using linear prediction, whereby the target signal spectral envelope is estimated by an all-pole IIR filter. In linear prediction coding, the all-pole filter replaces the bandpass filter bank of its predecessor and is used at the encoder to whiten the signal and again at the decoder to reapply the spectral shape of the target speech signal. One advantage of this type of filtering is that the location of the linear predictor's spectral peaks is entirely determined by the target signal, and can be as precise as allowed by the time period to be filtered. This is in contrast with vocoders realized using fixed-width filter banks, where spectral peaks can generally only be determined to be within the scope of a given frequency band. LP filtering also has disadvantages in that signals with a large number of constituent frequencies may exceed the number of frequencies that can be represented by the linear prediction filter. This restriction is the primary reason that LP coding is almost always used in tandem with other methods in high-compression voice coders. Waveform interpolative equals. Waveform interpolative vocoder was developed in AT&T Bell Laboratories around 1995 by W.B. Cleage, and subsequently a low-complexity version was developed by AT&T for the DoD Secure Vocoder competition. Notable enhancements to the WI coder were made at the University of California, Santa Barbara. AT&T holds the core patents related to WI, and other institutes hold additional patents. Using these patents as a part of WI coder implementation requires licensing from all IP holders. Artistic effects. Uses in music equals. For musical applications, a source of musical sounds is used as the carrier, instead of extracting the fundamental frequency. For instance, one could use the sound of a synthesizer as the input to the filter bank, a technique that became popular in the 1970s. History. Werner Meyer-Eppeler, a German scientist with a special interest in electronic voice synthesis, published a thesis in 1948 on electronic music and speech synthesis from the viewpoint of sound synthesis, and later he was instrumental in the founding in 1951 of the Studio for Electronic Music of WDR in Cologne. One of the first attempt to divert a vocoder to create music may be OE Siemens synthesizer at the Siemens Studio for Electronic Music, developed between 1956 and 1959. In 1968, Robert Moog developed one of the first solid-state musical vocoder for the Electronic Music Studio of University at Buffalo. In 1968, Bruce Hook built a prototype vocoder, named Farad after Michael Faraday, and it was first featured on the Electronic Record for Children released in 1969 and then on his rock album The Electric Lucifer released in 1970. In 1970 Wendy Carlos and Robert Moog built another musical vocoder, a 10-band device inspired by the vocoder designs of Homer Dudley. It was originally called a spectrum encoder-decoder, and later referred to simply as a vocoder. The carrier signal came from a Moog modular synthesizer, and the modulator from a microphone input. The output of the 10-band vocoder was fairly intelligible, but relied on specially articulated speech. Later improved vocoders use a high-pass filter to let some sibilance through from the microphone. This ruins the device for its original speech coding application, but it makes the talking synthesizer effect much more intelligible. Carlos and Moog's vocoder was featured in several recordings, including the soundtrack to Stanley Kubrick's A Clockwork Orange in which the vocoders sang the vocal part of Beethoven's Ninth Symphony. Also featured in the soundtrack was a piece called Timesteps, which featured the vocoder in two sections. Timesteps was originally intended as merely an introduction to vocoders for the timid listener, but Kubrick chose to include the piece on the soundtrack, much to the surprise of Wendy Carlos. In 1972, Eyes Automata's first electronic music album Electric Samurai, Switched on Rock was an early attempt at applying speech synthesis technique through a vocoder in electronic rock and pop music. The album featured electronic renditions of contemporary rock and pop songs, while utilizing synthesized voices in place of human voices. In 1974, he utilized synthesized voices again in his popular classical music album Snowflakes Are Dancing, which became a worldwide success and helped popularize electronic music. Emerson, Lake and Palmer used it for the album Brain Salad Surgery 1973. Kraftwerk's Autobahn was one of the first successful albums to feature vocoder vocals. Another of the early songs to feature a vocoder was The Raven in the 1976 album Tales of Mystery and Imagination by progressive rock band The Alan Parsons Project. The vocoder also was used on later albums such as I, Robot. Following Alan Parsons' example, vocoders began to appear in pop music in the late 1970s, for example, on disco recordings. Jeff Lynne of Electric Light Orchestra used the vocoder in several albums such as Time. ELO's songs such as Mr. Blue Sky, and Sweet Talkin' Woman, both from Out of the Blue, use the vocoder extensively, as does The Diary of Horace Wimp from the album Discovery. Featured on the album are the EMS Vocoder 2000 WMKI, and the EMS Vocoder 2000. Giorgio Moroder made extensive use of the vocoder on the 1975 album Einzelgänger and on the 1977 album From Here to Eternity. Another example is Pink Floyd's song Dogs, from their album Animals, where the band put the sound of a barking dog through the device. A vocoder was used by Joe Partridge to produce the Martians' unearthly exaltations of Allah in the 1978 concept album Jeff Wayne's musical version of The War of the Worlds. The vocoder has been used at the start and end of the Main Street Electrical Parade at Disneyland and Walt Disney World since 1979. Phil Collins used a vocoder to provide a vocal effect for his 1981 international hit single In the Air Tonight. Vocoders are often used to create the sound of a robot talking, as in the Styx song Mr. Roboto. Roger Taylor of Queen used the vocoder on 2 songs on Queen's 11th studio album The Works, Radio Gaga, and Machines. Vocoders have appeared on pop recordings from time to time ever since, most often simply as a special effect rather than a featured aspect of the work. However, many experimental electronic artists of the New Age music genre often utilize vocoder in a more comprehensive manner in specific works, such as Jean-Michel Jarre and Mike Oldfield. There are also some artists who have made vocoders an essential part of their music, overall or during an extended phase. Examples include the German synth-pop group Kraftwerk, Stevie Wonder and jazz fusion keyboardist Herbie Hancock during his late 1970s period. In 1982 Neil Young used a Sennheiser vocoder VSM201 on 6 of the 9 tracks on Trans. Tommy James used a vocoder in the production of his group's 1968 #1 hit Crimson and Clover. Perhaps the most heard, yet often unrecognized, example of the use of a vocoder in popular music, is on Michael Jackson's 1982 album Thriller, in the song PYT. During the first few seconds of the song, the background voicings "ooh, you," behind his spoken words, exemplify the heavily modulated sound of his voice through a vocoder. The bridge also features a vocoder as well, courtesy of session musician Michael Bodica. Coldplay have used a vocoder in some of their songs. For example, in Major Minus, and Hurts Like Heaven, both from the album Milo Xyloto, Chris Martin's vocals are mostly vocoder processed. Midnight, from Ghost Stories, also features Martin singing through a vocoder. In O, from the same album, Martin can be heard repeating Don't Ever Let Go into a vocoder. Noisecore band Atari Teenage Riot have used vocoders in variety of their songs and live performances such as Live at the Brixton Academy alongside other digital audio technology both old and new. Among the most consistent uses of vocoder in emulating the human voice are Daft Punk, who have used this instrument from their first album Homework to their latest work Random Access Memories and considered the convergence of technological and human voice the identity of their musical project. For instance, the lyrics of Around the World are integrally vocoder processed, Get Lucky features a mix of natural and processed human voices, and Instant Crush features Julian Casablancas singing into a vocoder. Voice effects in other arts Robot voices became a recurring element in popular music during the 20th century. Apart from vocoders, several other methods of producing variations on this effect include, the Solnovox, Talkbox, and Auto-Tune, linear prediction vocoders, speech synthesis, ring modulation and comb filter. Vocoders are used in television production, filmmaking and games, usually for robots or talking computers. The robot voices of the Cylons and Battlestar Galactica were created with an EMS Vocoder 2000. The 1980 version of the Doctor Who theme, as arranged and recorded by Peter Howell, has a section of the main melody generated by a Roland SVC 350 vocoder. A vocoder was also used to create the iconic voice of Soundwave, a character from the Transformers series. In 1967, the Super Marionation series Captain Scarlet and the Mysterons used a vocoder to supply the deep, eerie threatening voice of the disembodied Mysterons, and well as the bass tones for the Spectrum agent Captain Black when he is seized under their telepathic control. It was also used in the closing credits theme of the first 13 episodes to provide the synthetic repetition of the words Captain Scarlet. See also, Homer Dudley, Voda, Phase Vocoder, Silent Speech Interface, for musical applications, Werner Meyer Epler, List of vocoders, Auto-tune, Audio timescale pitch modification. References. Multimedia references. External links, How Vocoders Work from PAIA, Penn State Basic Voda vocoder operation with simple diagrams, description, photographs, and diagram for the vocoder at 120years.net, Vocoder tutorial. Description of a modern vocoder. GPL implementation of a vocoder, as a Ladesper plugin, O'Reilly article on vocoders, object of interest, the vocoder, the New Yorker magazine mini documentary.